Okay, let's talk about perpendicular lines. All right, now, we might get something that asks us the following. Show that the two following linear equations are perpendicular to each other. I know we have already talked about parallel. We would know that they would just be the same gradient, but that is a bit different to this. Well, if we want to know if two lines are parallel to each other, that's easy. But perpendicular, well, we need this little equation here. Two linear equations are perpendicular if, when you multiply their two gradients, these two gradients, it will equal -1. Okay, so if we do that for this particular instance, we would say that we've got our m1, which is -3, our m2, which is 1/3. When you multiply the two of them together, you get -1. Therefore, this is proven to be true, and the two linear equations are perpendicular to each other. Okay, it really is as simple as that. You multiply the two gradients together. If the answer is -1, they are perpendicular. I do have a nifty little Desmos graph I can show you here. Okay, so you can see I've got two parallel lines, a red one and a purple one, I guess. And it doesn't really matter what I change in terms of the gradient of this line, except for when it is 0. When m is 0, well, yeah, anyway, you don't need to really worry about that. So no matter what this is, we will end up with parallel lines. So here, this formula is saying that this red one is y equals mx plus 1, whereas the blue is y is -1/mx plus 1. So it's using the same value for m in both of these different equations, okay, these linear equations. And what they've done down here is they've shown that m multiplied by -1/m, it is always -1. And it doesn't matter what these are, the value for m, it doesn't matter. They are always -1. Look, except for this one, where we've got m is equal to 0. The reason why it's saying undefined is because if our value of m is 0, then this -1/m, it's impossible to do. We can't divide a number by 0. It's undefined. It has no answer. So for every instance where a gradient is either greater than or less than 0, but not equal to 0, this perpendicular line rule will hold true. Okay, so we can use that in situations. Let's have a look at some of those, shall we? Our first one, we might get something like this. Calculate the gradient of a linear equation that is perpendicular to y equals -4x plus 6. Well, this is pretty easy. We know our rule, the two gradients multiplied together equals -1. And here we don't actually have the second gradient, but we don't really need to. So I write down, after I substitute in, the fact that my first gradient is -4. Now that comes from this point right here, -4x, that's our gradient. I can then say, well, how do I get this second gradient by itself? Well, here I need to get rid of the -4, and it's being multiplied. So I have to divide both sides by -4. And when I do that, I end up with -1/-4, which equals 1/4. So the gradient of that perpendicular line to this first linear equation will be 1/4. So it's pretty easy, really. It's not too difficult. One you might get that's slightly trickier, let me move it over a bit, is you might need to identify a linear equation that is perpendicular to another linear equation and it passes through a particular point. Okay, this one requires a little bit more thinking. So we first write down our linear equation, and there it is there. But this doesn't fit our general form of a linear equation. Remember, our general form just has a y on one side of the equation. And so we need to work this equation that we've been given until we have just a y over this side. So all we do is we say, well, we can divide by 3. We'll divide everything by 3. And we end up with a form that looks very similar to the one that I wrote in red there. Okay, so we can do what we did just before. We can identify the gradient of that other perpendicular line. Okay, so we can substitute in our line gradient of 4. We can figure out that the second gradient is going to be needed to be negative 1 over 4. Okay, so it's all going fine so far. Now this is where we need to do a little bit more work. So we're writing down in a different colour here. This is the second linear equation. This is the one that's perpendicular to that first one. And it is asking me, if you remember, to put it through the point -2 and 8. So all I need to do is think about the case for this specific linear equation of -1 over 4x plus c, where x is that -2 and y is equal to 8. Okay, so I substitute those things in. I then will get c by itself. So I'm going to multiply -1 over 4 by -2, get 1/2. I'm going to take 1/2 from both sides, and I am going to, oh, my board just crashed. Oh dear. So I am going to take -1/2 on both sides so I can get c by itself, and I find that my value of c is equal to 7.5. So I can say that y is equal to -1/4 x plus 7.5, and that is the linear equation of the perpendicular line that passed through that point of -2, 8. Okay, so we can use this idea of perpendicular lines, and we can just calculate two other linear equations passing through any point. Okay.